Okay, let's talk about using similarity to find unknown sides. Essentially, knowing that two triangles are similar helps us because we can use the information from one triangle to determine unknown information about the other. And before we get started, we're going to use this little symbol here, or it's important to know what it looks like. I'm just going to write an exaggerated version of it. Okay, often we'll just write it as a little squiggly. That means that it is similar to, and that's the mathematical form we're going to use in some of our problems here. So let's talk about the steps to find unknown sides using similarity. We're going to start with the exact same steps that we used when we were finding the scale factor. So first and foremost, we need to match up the sides with each other and redraw the triangle if it helps. We're then going to determine the scale factor between the triangles. And then we need to ask ourselves, am I multiplying or am I dividing? So I'm going to choose multiplication if I need to use information from the smaller triangle to get to the larger triangle, and that makes sense, right? I'm going from small to big. I'm going to use division if I'm going from the larger triangle down to the smaller triangle. And then we find the unknown side. So let's do an example here. Given that triangle ABC is similar to triangle DEF, find the value of x, round to 1 decimal place. That's our first instance of seeing that is similar to symbol, okay, that we're going to see throughout this problem. So first and foremost, let's start by matching our sides up with one another. My single loop is going to be green. My double loop is going to be pink. And finally, my last side is going to be blue. I don't feel the need to redraw these triangles because they are already in the same orientation and pretty straightforward. Now I need to match up the sides, or I need to find my scale factor. In order to find the scale factor, I'm going to divide my green sides by each other because they're the only ones that have both pieces of information. They have the information for both triangles. So I'm going to go 24 divided by 16. I can reduce that by dividing the top and the bottom by 8, leaving me with 3 over 2, which is about 1.5. Now I'm going to set up what my similarity statements are. So I'm going to say, again, we're going smaller to larger, so I'm going to say 16 is similar to 24. Small triangle first, large triangle second. I then have to say, well then x is similar to 21. Now remember, how did we get from 16 to 24? Because we're going from the small triangle to the large triangle, okay, now that I've found my scale factor, I need to set up my similarity statements, okay? We have information about our large triangle, and we're going to be going to the small triangle. So I'm going to write that I have my large triangle, and I'm going to my small triangle. Well, the first statement that I can make is that, well, 24 is similar to 16. I then can also say that 21 is similar to x, and we're going to use our little similar tool in between. Now I need to pick, am I multiplying or am I dividing? Well, I'm starting from large, I'm going to small, which means I need to divide. So 24 divided by our scale factor is equal to 16. We can just double check that on our calculator. We can say 24 divided by 1.5 is equal to 16. So we know that this statement is true. I then can do the exact same thing in order to find x. I can say, well then 21 divided by 1.5 has to give me x. 21 divided by 1.5 is 14. So I can say, therefore, x is 14. Let's look at a second more complicated triangle. Given the triangle ABC is similar to triangle RPQ, find the value of x and y. And we're going to round to 1 decimal place. Okay, we haven't been given any information here about our angles, and so it is a little bit harder to match it up, but fortunately it is obvious enough that we are going to be able to succeed. I can start immediately. I can just say, well, my long side on both triangles has to match up. Therefore, that's the one there. Then I have a medium side, so my medium side has to match up. And finally, my short side has to match up. Okay, now from here, you could redraw the triangle if you needed to. I don't need to in this case, but that is an excellent solution for you. Actually, why not? Let's just do it. Let's redraw this triangle. I'm going to redraw the big one underneath. So I'm going to start by just drawing the general shape. Again, it doesn't have to be perfect because we have all of the numbers that we need. A little bit too long. Okay, I'm going to start by saying, okay, well then this has to be side blue because we're following the same shape. The bottom side is side pink, and the last side is side green. I can then match up my side information, so green was 7.8, blue is 17.3, and X is pink, and then finally I can just relabel. Q is going to be up here, R is going to be down here, and P will be in our bottom left-hand corner. Now I need to find my scale factor, so I need to see, okay, which colored side do I have information for in both triangles? If I look at pink, my pink side, I only have the smaller triangle information. I only have 4.2, so I can't use that one. If I look at my blue side, I only have the larger triangle information, so I can't use that. So I have to use green. I have to use the green side because I have information from both the small triangle and the large triangle. So I need to say, okay, my scale factor is going to be equal to 7.8 divided by 6. I'm going to jump immediately to the calculator in order to do this one. 7.8 divided by 6 is 1.3. Nice and easy, okay. Now I need to set up my similarity statements. First, we're going to solve for x. In order to solve for x, x is on the large triangle, so that means that we need to start from the small triangle. So I'm going to go from my small triangle to my large triangle, small to large. I'm going to say that my green sides, I start from 6 and I go to 7.8. These are similar. X matches up with pink, so I'm going to start from 4.2 and somehow end up at X. Because we're going from small to large, we need to multiply by our scale factor. So I'm going to multiply by 1.3. Let's just double check and make sure that makes sense. 6 times 1.3 is 7.8. So I've written this equation right. That means that I can do 4.2 times 1.3, and that will give me X. I need to round to 1 decimal place, so I can say therefore X is 5.5. Now let's do this for Y. Y is in my smaller triangle, which means I have to start from large and go to small. Again, I'm going to use my green side because that was the information from the question, so it is the most accurate. The green side here is 7.8, and my small side is 6. They are similar. And this time, because I'm going from large to small, I divide by my scale factor, which is 1.3. In order to find Y, I need to match up the blues, so I say my large triangle is 17.3, and that matches up with Y. So if we just double check here, That's 7.8 divided by 6. No, 7.8 divided by 1.3 gives me about 6. Okay, so we know that that's right. So 17.3 divided by 1.3 gives me about 13.3. And that is the answer for y. Okay, so remember, when you're trying to find an unknown side, you're going to follow the very similar steps that we had seen for finding the scale factor. You match up the sides, you find the scale factor, you're going to write your similarity statements, decide if you're multiplying or dividing, and then just find the unknown side. Good job, everyone!